Okay, check this. 2018, seventh question. A part and B part is there, but B part is under turning effect of force. We will discuss the B part under that topic. For now, we will discuss the A part. Read the questions. A tall cubical block of wood of mass 800 gram was placed on a horizontal table. Yeah, we are keeping a block of wood of mass 800 gram. If they give something in any units like milligram, gram, uh, yeah, if they give in those units, it should be converted to the SI unit. What's the SI unit? SI unit of mass is kilogram. So if they give in gram, we should convert it into kilogram. How are you going to convert? We should divide this by 1000. To convert kilogram to gram, we should multiply by 1000. Okay. So if I convert it, we will get zero point 0.8 kilogram. So in Roman number 1, A part, calculate the weight of the block of wood. You know the equation. What is the weight of the block of wood? Weight is mass into gravitational acceleration. You know the mass. This mass should be in kilogram, not in grams. zero point 0.8 into 10 meter per second minus 2. So you will get 8 Newton. 8 Newton is the weight of the block of wood. And the B part, force exerted by the block of wood on the table is equal to weight of the block of wood. How much is the reaction exerted on the block of wood by the table? This is Newton's third law. This is according to Newton's third law. Now, according to Newton's third law, every action has an equal and opposite reaction. This block of wood is exerting a force of 8 Newton in the downward direction to the surface, the flow on the table. This table will exert the same 8 Newton force in the opposite direction, in the upward direction, on the block of wood, that is 8 Newton, and that is equal to perpendicular reaction. That 8 Newton is equal to perpendicular reaction. So answer should be 8 Newton. So what's the answer? Answer 8 Newton. Name the Newton's laws of motion that is relevant to the phenomena by which the answer for A was obtained. That is what Newton's third law. Newton's third law. Now we will see the marks allocation for this. Weight. For this substitution, they have given 1 mark. For the answer, they have given 1 mark. And also it is said the unit is must. If unit is not given, if you just put 8, you won't get this 1 mark. You should put 8 Newton. If you put 8 Newton only, you will get this 1 mark. And then D part, this also you get 1 mark. And to write this as Newton's third law, we get another 1 mark. This is the marks allocation. Now we will see the next set of questions. Of point A and B, which is suitable to apply a force in order to move the block of wood horizontally on the table as shown in the figure 1. Of force of point A and B, which is suitable to apply a force in order to move the block of wood horizontally on the table as shown in the figure. State the reason for your answer above. Now, this you can think practically and you can get the answer for this. Here, I have a long block of wood, and it is said that this surface has friction, and they have also marked the friction. They haven't said that this surface is smooth or rough, but you see that they have marked the force F. Force F friction is marked here. They have marked the friction. Friction is marked here. And they are asking of these 2 points A and B, which is suitable. These 2 points A and B, which is suitable to apply a force, which is suitable. Point A or point B. Now think like this. Right, Julia? I have taken this paper. I am okay. I have taken this paper. Now assume that I am giving a friction here. I am giving a force here. I am giving a force here, like this. So if I need to make this sheet of paper to move in the forward direction, let's see, I'm applying a force here so I can move it. Okay, now I'm going to take the hand bit upward. Still now I can move it. I'm going to take it further upward. Still now I can move it. But you can see it is bit slanting, right? But when you keep the hand on the top, if I try to pull it, you can see that this sheet is trying to topple. This sheet is trying to slant. It means it's trying to topple. This is what happening in this block of wood. Now here there is friction acting on this point because this point is in contact with the surface. This point is in contact with the surface. Because it's in contact with the surface, there will be friction in the backward direction. So if the force that I'm applying is more collinear for this one. What do you mean by collinear? The force should be in line with this friction. If this force that I'm giving is, if this force that I'm giving is more collinear for this, then this object will not topple. Here I can pull it. If this F1 force is greater than F, I can pull this in the forward direction. This is forward direction. Assume this is forward direction. I can pull this block of wood in the forward direction. It will not topple. Topple means it will not fall like this. But when I take this force bit upward, if I take somewhere here, there is no problem. In the middle also no problem. But if I take this force F1 somewhere like this or somewhere like this, what will happen? Couple will be created. Now, this point can be explained practically, but also it can be take the turning effect of force. From that also we can explain. Here, it's like this, right? I'm giving a force like this and also giving a force like this. Force like this, force like this. Force like this, force like this. Therefore, this object will try to topple like this. Therefore, I can't take this block in the forward direction. It will topple. But if I give a force somewhere near to this force, in collinear, it is much more better. If it is in collinear, it is much more better. But if I take it further away, also it is bit okay. But if I take it far away, if I take this point far away from this force, then it will topple. We can't move in the forward direction. Therefore, the best point is point A. Point A should be the answer. State the reason for your answer. Let's see the answer. Yeah. A more collinear the applied force and the frictional force against it, the tendency for toppling the block of wood is less. Less tendency for applying moment decreasing. Yeah, a moment will be created if this force is taken further away from this force. If the given force is more collinear for this force, if the given force F1 is more collinear for this one, then I can move the block in the forward direction. If this force given F1 is further away from this force, then the object will try to topple. Object will try to topple. We can't move in the forward direction. Yeah, that is what is said. The applied force should be more collinear to the frictional force. And what is the advantage of this? Is the tendency for toppling the block of wood is reduce. Tendency for the block of wood to topple will reduce. And also tendency for applying moment decreasing. And if you write any of the one point, there are 2 points that you can write. 2 points in the sense, two way of giving the answers. One way is the given force should be collinear to the applied force. So the tendency for toppling the block of wood is less. That should be the first one of answer. Other choice is when given force the given force, the applied force is more collinear to the frictional force. The tendency for applying moment decreases. Either way, you can give the answer. And for this, for giving A as the choice, you will get the 1 mark. And for reason, you will get another mark. Now we'll move to the next point. Okay. Check the next question. Of A and B above, a Newton balance was connected to suitable point and a gradually increasing horizontal force X was applied. Shown in the figure 2 was the graph shown in the figure 2 was obtained. By what name the frictional force exerted on the block of wood? I have explained this in detail in the MCQ part which we have done in 2022. 2022, there were two questions, statement questions, there were two questions. I think it's the 32nd MCQ or something. You can check the recording. I have explained to you in detail what is happening if the force is given, what is happening, and yeah, let me explain to you again. By what name is the frictional force exerted on the block of wood known when the force exerted on it is 3 Newton? Now, let me try. I'm going to clean this. Is the graph given? So here we have the maximum static friction or the limiting friction. Maximum static friction or limiting friction is what's the force? That is 4 Newton. 4 Newton is the maximum static or limiting friction. If the given force in the forward direction is less than 4 Newton, object will not move. So at that instance, what is the static friction? That static friction is equal to the force that we have given. Now the maximum static friction is 4 Newton now. If I apply 1 Newton, then yeah, the force applied. Now let us take this as FP. FA. FA is force applied, right? FA. FA is force applied. If I apply 1 Newton, then the static friction is 1 Newton. If I apply 2 Newton, static friction is 2 Newton. If I apply 3 Newton, static friction is 3 Newton. If I apply 4 Newton, static friction is 4 Newton. But if I apply 4 Newton, there is no static friction. What's the friction that will act? Here we have the dynamic part. Dynamic friction will be acting. No static friction. Dynamic friction will be acting. When the given force is greater than the maximum static friction or the limiting friction, then the dynamic friction will be acting because the object will be in motion. Okay, this is what I have explained in 2022 MCQ also. Check it. By what name is the frictional force exerted on the block of wood known when the force exerted on it is 3 Newton? When the force exerted is 3 Newton, then the frictional force is known as the static friction. So if 3 Newton force is given, what is the part of the graph? This part of the graph is static friction. This part of the graph is dynamic friction. This is limiting friction. That is limiting friction. So that's it. What should be the answer? Answer should be static friction. Answer should be static friction. In Roman number 3, A part, static friction. Marks 1 mark given. Is it 1 mark? Yes, 1 mark given. What is the next question? What is the limiting friction force exerted on the block of wood as indicated in the graph? Limiting friction is 4 Newton. So in B part, limiting friction is 4 Newton. For this also we have given 1 mark. It was required to drag a large block of wood along a flat rough surface. They have said flat rough surface. Then the surface has friction. It is a frictional surface. State two different methods that can be used to reduce the friction between these surfaces. What are the methods that is given in the book? See the short note which I have sent you. Under friction. Methods to reduce friction. Apply boric powder. Apply lubricants. Apply grease. Insert ball bearing. Likewise, insert bearings. Bearings of two types as ball bearing and there's another type of bearing. If you need any further detail, you can check the YouTube. Ball bearing is something like this. Uh, I'm going to clean this. If you want, take screenshot. Red color marker is not visible, right? This is limiting friction. We'll use a blue color marker. Okay, this should be the answers. If you want, take a screenshot. Bearing is something like this. Now, for this gates, they are using this bearing. Now, here there will be a metal sheet. There will be a iron or metal something. Here also there will be iron. Now, when these two get in contact with each other, there will be friction between both of them. Now, if the size is bigger, this both will get in contact with each other. Friction increases. Therefore, the work will not be smooth. It means now these are used for the tires which are used in some small gears, right? Small gears are used in this bearing. Therefore, if these two surfaces get in contact with each other, this will not easily rotate. If they do not easily rotate, then it is difficult to open or close the door, or open or close the gate. Therefore, what they have used this bearing.